Hello, my name is Eric and I'm going to be your tutor. Um, so the first section would just be the addition of integers, and this is really basic stuff. It's not something I should have to go over. So we're just going to do one and then move on. So 6 plus negative 12 would be negative 6. And then negative 6 plus 2 is negative 4. That's just really basic stuff. It's not something I should have to go over. The greatest common factor, how I find the greatest common factor is like this. So you do this and you put in the numbers 5 and 15. Now, uh, is 5, uh, can 5 be divided by 2? Yes, but the answer would be 2.5. We're looking for whole integers right now. So in this time, 5 cannot be divided by 2. 5 cannot be divided by 3 either. Can 5 be divided by 4? No. Can 5 be divided by 5 though? Yes, it can. Can 15 be divided by 5? Yes, it can. So you put 5 and then you divide 5 and 15 by 5, which is 1 and 30. Now, because there's a 1 here, 1 can't be divided by 2, 3, 4, 5, and on. Which means that which means it gets stuck. And so we just put 1 here and end it. And then you multiply everything on the left side, which would just be a 5 this side. And this is how we find the GCF. Now, as for what the GCF is, the GCF is just a factor that they have in common. So 15, if you factor 15, it would be 1 through 5 and 15. If you factor 5, it would be 1 and 5. Now they have 5 and 5 in common and 1 and 1 common. But 5 is greater than 1. And trying to find the greatest factor that they have in common. So it would be 5. That makes uh, that's just a really rough explanation of it. Um, the next question would be 12 and 44. Now, can 12 be divided by 2? Yes. Can 44 be divided by 2? Yes. So it'd be 6 and 22. Can 6 be divided by 2? Yes. Can 22 be divided by 2? Yes. So it'd be 3 and 11. Now, can 3 be divided by 2? No. Can 3 be divided by 3? Yes. Can 11 be divided by 3? No. And 4 is greater than 3, so we're never going to get an answer anymore, which means it's just a 1. And so you multiply everything on the left side, and you get a 4. Okay, so this is how you find GCF. It's pretty simple, so I'm going to be moving on. Now, for LCM, it's basically the same thing, just with one extra step. So, same as before, you put 9 and 18 here. Can 9 be divided by 2? No. Can 9 be divided by 3? Yes. Can 18 be divided by 3? Yes. So it'd be 3 and 6. Can 3 be divided by 2? No. Can 3 be divided by 3? Yes. Can 6 be divided by 3? Yes. Okay. Now 1 and 2. Now for GCF, we would have ended here. But now, since the only answer is 1, we just put 1 here. And then we divide 1 by 1 and 2 by 1. And so in GCF, we just multiplied everything on the left side. But this time, we're going to be multiplying everything on the left side and on the bottom as well. So as long as it's not inside of these little things, we're going to be multiplying. So 3 times 3 is 9. 9 times 1 is 1. 9 times 1, no, 3 times 3 is 9. 9 times 1 is 9. 9 times 1 is 9. And then 9 times 2 is 18. So the LCM would be 18. What the LCM is, here. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. Now 18 times 1 is 18. 18 times 2 is 36. Okay. Now the smallest number that they have in common would be 18. Obviously 9 times 4 is 36, so that would also be common, but we're trying to find the smallest common multiple, or which in this case would be 18. We're going to do one more. So 3, 19. Can 3 be divided by 2? No. Can 3 be divided by 3? Yes. Can 19 be divided by 3? No. So it's just a 1. So you put a 3 and a 19 here. Now what's 1 times 3 times 19? 1 times 3 times 19 is, it's a 57. okay? So the LCM would be a 57, and it works on the same principle as up here. Let's go over to the next section, which is percentage word problems. Now, in percentage word problems, the main thing is you want to find out what they're asking for. What they want to know is how many M&Ms are not red. And what it tells you is how many M&Ms are red. It says that 30% are red. But if 30% are red, that means 70% aren't red, okay? Right? Yeah. So 70% is actually just 70 over 100, right? And so now we know that now we have this, and then equals. We're trying to find how many M&Ms are not red. So we're trying to find x, and what we're trying to find x over is that we have a total of 40 M&Ms. Okay, just like 1 is 100%. The total 100% of the M&Ms is 40, and 70% of the M&Ms is x. So now we're just going to simplify. Now when you want to simplify, you can only simplify up and you can only simplify across. You can't simplify across, or you can't simplify diagonally because you're going to be multiplying diagonally. Here, let me. When you multiply, you're going to be multiplying like this. So 1 times x and then 4 times 7. So you can't, if you try and factor diagonally, you're going to mess something up. So what we want to do is factor across and factor up. So then this would be x is equal to 28 because 4 times 7. So 28 of the 40 M&Ms are not red because 28 is 70%. Make sense? Yeah. Here, let's do number 5 now. So a toy car costing 59% is reduced by 10% in the sale. How much does it cost now? So before it cost $59, okay? And what we're trying to find is how much it costs now, which is x, okay? Now, if you saw this question and you just looked at the numbers and gave it a quick glance, you probably would have put 10 over 100. But this isn't what it is, okay? Because right now, what it's saying is that 100% is 59, okay? $59 is equal to 100%. And so now you're reducing that 100% by 10%. So what's 100 minus 10? It's 90, right? Right. So then what you're trying to find is not 10% of 100 or 10% of 59, you're trying to find 90% of 59. So same as before, you just simplify and then multiply. So 10x is equal to 59 times 9. What's 59 times 9? 59 times 9 is 1, it's 531, okay? Now you divide by 10 to get x is equal to 53.1. And so it would be $53.10. So that's how you do percentage problems. Have a nice day.